Good morning, it's Mr. Michelin here, and this is a very short video on the second application of thermodynamics that we're looking at. The first being household, and the second one being, I suppose, a little bit on climate change, global warming, and I suppose more specifically, the greenhouse effect. So in this video, we're just going to go through and talk about what is the greenhouse effect, and how is it different from the advanced greenhouse effect? How do we describe what's going on? And what are some of the things that are responsible for the greenhouse effect? So, I'm sure many of you have heard of the term greenhouse effect, and especially with global warming being the hot science topic in society and politics at the moment. Let's actually have a look at what's really going on. Let's draw a picture of the planet. So there's lovely planet Earth. And here are some land masses. I'm sure you're all going, what land mass is that, sir? The most important one, though, is there is Australia. And when scientists are doing, I suppose, studies on thermodynamics of, what's going on in the solar system and on different planets with regards to heat and heat energy, if you were to examine the Earth as a purely, and just sort of go, I'm just going to have a look at how much radiation is coming in and how much radiation can the Earth possibly absorb, and how much would it be re-radiating, and how much radiation would be being reflected. And the average temperature of the Earth, should be about minus 15 degrees Celsius. If we were just to look at the planet from a purely how much energy is incoming, how much is the planet absorbing, how much is the planet re-radiating, how much is the planet reflecting, just the planet itself. And obviously our planet is, so this mathematical modeling works very well for some of the other planets. But for the planets that have an atmosphere that's made up of very particular chemicals, there's a massive difference between what we predict the temperature should be and what the temperature actually is. The average temperature on Earth is actually, so the average temp on Earth is approximately 15 degrees Celsius. So obviously it's hotter in some places and colder in others. That's the average temperature. So we can see there's a massive difference between what is predicted by modeling and what actually is occurring. So what is responsible for this what's responsible for this difference? And the answer is greenhouse effect. So the greenhouse effect is responsible for our planet, and not just our planet, but other planets as well. For example, Venus, with its very heavy atmosphere, is a lot hotter than what is predicted. But we're talking about just Earth in particular. So the greenhouse effect is responsible for our planet being warmer than predictions would suggest. And that is not necessarily a bad thing. If the planet was minus 15 degrees, we would have no liquid water anywhere and life just would not have taken off here. Okay, so the greenhouse effect, the natural greenhouse effect, is actually very beneficial for life on this planet. Okay, so it's responsible for the planet being warmer than the predictions would suggest, and it occurs because some chemicals, not all, some chemicals in our atmosphere are good at absorbing and re-radiating thermal energy. Right, so our atmosphere, so our atmosphere is not as thick as I'm sort of making out to be on our drawing. Our atmosphere, so if our planet was a basketball, the atmosphere would be maybe the thickness of a couple of pieces of paper. That's not very thick at all. But just so we can try and make things sort of a little bit clearer, there's our atmosphere. Here is some incoming radiation from the sun, which we need. And that obviously so some of it is actually reflected off the atmosphere. Some of it makes it through, some of it is absorbed into the Earth. And things like the polar ice caps would reflect a lot more. So we might get some of the radiation being reflected off the planet. Some of it's absorbed. But as some of it is reflected outwards, our atmosphere also catches some of it and then re-radiates it back down. And that's what allows our planet to try and retain some of the thermal energy that's being bombarded at us by the sun. So the sun is shining on us with all of its lovely radiation. Some is reflected off our atmosphere. Most of it makes it through. Some of it's absorbed. Some of it is reflected, and the stuff that is also absorbed would then be radiated as well. But as it's beginning to leave the planet, as the radiation sort of leaves and it's traveling through the atmosphere, some is absorbed into the atmosphere and then it's re-radiated in all directions, and some of that is back towards the planet, and that allows the planet to be a little bit warmer than we would predict. That's the natural greenhouse. Oh, you come back here. That's the natural greenhouse effect that we actually need to support life on this planet. Now, in our atmosphere, if we think about what are the chemicals in our atmosphere, we've got a lot of nitrogen, we have a lot of oxygen, we have sort of some small amounts of water, some carbon dioxide, and a couple of other trace materials. The bulk of our atmosphere, however, is these two materials here, nitrogen and oxygen. And they are two diatomic molecules. Okay, so two molecules that have two atoms. And these play no part. Okay, nitrogen and oxygen play no part in the greenhouse effect because the diatomic molecules appear to be no good at absorbing thermal radiation. Okay, they appear to be no good at it whatsoever. Of the two materials that are left, hydrogen and carbon dioxide and water, water is the major player. It is the water in our atmosphere that is the main contributing greenhouse gas to the natural greenhouse effect. Carbon dioxide plays a small role. And because if we have a look at the Earth's history over, several million years, and we can track what the atmosphere has been like for the past couple of million years, the amount of water vapor in the atmosphere remains relatively constant. And when we see small fluctuations in the carbon dioxide level, we see some very small fluctuations in the Earth's temperature. Okay, so when the carbon dioxide level rises a little bit, the temperature rises a bit most of the time. When it falls a little bit, the temperature reduces a little bit. Most of the time, that rule is not always obeyed. But it's the H2O in our atmosphere that is the major greenhouse chemical. It's the major greenhouse gas. Okay, not carbon dioxide like lots of people think. Okay, it is the H2O that is the major greenhouse gas that contributes to the natural greenhouse effect, which we need. Okay, all right. So, how does that differ from the advanced greenhouse effect? Well, the advanced greenhouse effect and the natural greenhouse effect are essentially the same. The mechanics of it is essentially the same. You have some radiation coming in from the sun, and some of it is trapped by some of the chemicals in our atmosphere. But the difference between the advanced greenhouse effect and the natural greenhouse effect is there's an increase in CO2 and other gases. For example, methane is another gas that's very good at absorbing thermal energy. But the amount of water vapor in our atmosphere has remained relatively constant. The amount of water available on the planet, period, is constant. Okay, it's a closed system. So the contribution of water vapor to the greenhouse effect has remained fairly constant. So any major change that we see with regards to, I suppose, temperature or the amount of thermal energy that's being trapped by the planet has to be attributed to other chemicals, such as carbon dioxide and other gases. So in terms of the advanced greenhouse effect, we're seeing an increase in the contribution of carbon dioxide. And so it has an increased contribution. Water vapor, though, is still the main greenhouse gas because it makes the largest contribution. But because we have increased amounts of carbon dioxide for plenty of different reasons, then the role of carbon dioxide has increased proportionally. Okay? So, the greenhouse effect, the natural greenhouse effect, we need. Otherwise, life on this planet would not exist, and it's responsible for making our planet a bit warmer than we would predict, and it occurs because some of the chemicals in our atmosphere are good at absorbing and re-radiating thermal energy, and those chemicals are mainly water vapor with a small contribution from carbon dioxide gas. And we have a nice little diagram to sort of show, okay, what's going on with the greenhouse effect. If we sort of think about the advanced greenhouse effect, which is what's occurring today, so the natural greenhouse effect has been occurring for billions of years. Okay, or essentially for the half a billion years that life's been around on this planet. But the advanced greenhouse effect is something we're seeing in modern times because we're pumping a lot more carbon dioxide into the atmosphere. And so we're noticing, well, there's a bit more thermal energy being trapped by the atmosphere, and that's leading to a number of different issues, problems that are being seen across the world. Okay? So the advanced greenhouse effect and the natural greenhouse effect. Thank you.